So class question 1a, we are given figure 1. So the electric field at point 10 cm away from the charge P, as in figure 1, is 2.7 to the power of 6 Newton per Coulomb. Determine the charge of P. So we want to find the charge of P. What is the value of charge of P? Whereby the question tell you at a point 10 cm from this point charge, the electric field is 2.7 to the power of 6 Newton per Coulomb. So we already know about the electric field strength at that particular distance 10 cm, so we can relate with the charge of the point charge. So we use the equation E is kq over r squared. So the electric field strength at 10 cm is 2.7 to the power of 6, Coulomb constant 9 to the power of 9. So this electric field is produced by charge P, so over the distance. So the distance at that particular point to charge P is 10 cm. So 10 cm change to meter, 0.1 squared. So do our calculation, we will get the magnitude of the charge P. So it should be 3 to the power of negative 6 Coulomb. Okay, so we done question 1. Question 2, with reference to figure 1, a charge P is placed 10 cm away from charge P. So we have a charge Q, and then we place the charge Q 10 cm away from charge P. When charge Q is moved horizontally to the right to a position of 5 cm from its initial positions, there is a 0.54 joule change in its electric potential energy of the system. What is the charge of Q? So we want to find charge Q. So kita labelkan sebagai Q kecil lah. Okay, so kita nak cari berapa charge Q ni. So I denote it by small capital Q. So kita nak dapatkan nilai charge of Q. Apa maklumat yang kita tahu ialah kita tahu initially charge Q berada di sini. So this is the initial position, and then we move it from 10 cm to a final positions here. Okay, final, we put it here. This is the final position, whereby it's 5 cm away from initial positions. And then in order to move the charge, we find out that there is a change in electric potential energy of 0.54 joule. Okay, so we want to find the charge of Q. So class, if we refer to the concept we learned in topic 1, the change in electric potential energy, we can relate with the work done in order to move the charge. So the work done to move the charge is equal to the magnitude of the moving charge multiplied with the change of electric potential between the 2 points. So kita susun lagi. So change in potential will be the potential at final position minus the potential at initial position. Okay, so the change in potential energy is given 0.54. So the magnitude of the moving charge Q is the one that we want to determine. Then how we find the potential final and initial? So this potential final and initial is created by point charge P. So we have V is K, Q, so the Q here will be QP lah, over the R. the distance the final distance from point charge P minus V initial will be K Q charge P over R, the initial distance. Okay, then we put in the value. So Q kita nak kira, so 9 to the power of 9. So the charge P already determined from question 1, 3 to the power of negative 6 over the distance. The final distance will be 15 cm, so 0.15 minus, so K, 9 to the power of 9, the magnitude of charge QP, 3 to the power of negative 6 over the initial distance from charge P will be 0.1. Okay, then you might calculate the magnitude charge of Q. So when we do our calculations, we will get the magnitude of charge Q will be negative 6 to the power of negative 6 coulomb. Okay, then we done with question 2. Question 3, we want to sketch the electric force vector on charge P and Q. So class, charge P and charge Q, we already determined the value. So we want to sketch the electric force vector on charge P and Q. So I redraw the diagram. Okay. So this is charge P. So charge P is 3 to the power of negative 6 coulomb. And then we have charge Q, whereby charge Q is negative 6 to the power of negative 6 coulomb. So one is positive charge, one is negative charge. So we want to sketch the electric force vector on charge P. So because charge P is positive, charge Q is negative, so charge P will feel attraction force. So charge P akan rasa attraction force towards charge Q. Okay, so we label it as F P Q. Okay, at the same time, charge Q is negative, charge P is positive, so charge Q will experience also attraction force towards charge P. So we label it as F, Q, P. So this is the electric force vector on charge P and also charge Q. Then we're done with question 3. We move on to question 4. If charge Q is again moved horizontally to the right to a new position and the electric force on it is negative 4.05 Newton, how far apart is charge Q from charge P? So class, we want to find the distance between charge P and charge Q when the force acting on it is 4.05 Newton. So we can relate with the Coulomb electric force equation. F is K QP Q over R squared. So the force is 4.05. I just take the magnitude. K is 9 to the power of 9. So magnitude of charge P is 3 to the power of negative 6. Magnitude of charge Q is 6 to the power of negative 6 over, so the separation, the distance between the two charges. So when we do our calculation, we will get the R will be around 0.2 meter. Okay, then done question 4. Then we proceed to question B. A positively charged parallel plates are held 2 mm apart. A 4 to the power of negative 5 joule of wood is needed to move a 2 microcoulomb point charge from one plate to the other. Calculate the electric field between the plates. So kita nak cari E in between the two charged parallel plates. Okay, so I visualize the problem. Means that we have 2 parallel plates. Okay, so the separation between them is 2 millimeter, means 2 to the power of negative 3 meter. So the question said when we move a charge from one plate to another plate, we need to do work. The work we do will be 4 to the power of negative 5 joule. So the charge, the magnitude of the charge that we move is 2 microcoulomb. So we want to find the electric field between the plates. So class, this is a parallel plate, so the electric field will be given by the potential difference between the plate divided by the separation between the plate. So in order to solve the question to determine the electric field between the plates, we need to determine the potential difference. Okay, so how I'm going to determine the potential difference? So the potential difference can relate with the work done. So the work done is Q delta V. So I can calculate the potential difference first. So work done is 4 to the power of negative 5. The magnitude of the charge that we move is 2 to the power of negative 6, 2 microcoulomb delta V. So the potential difference between the two plates will be 20 volt. Then I put it here so I can find the E, the electric field between the two charged parallel plates. So 20 over the separation between the plate is 2 to the power of negative 3. So I'll get the electric field will be 10,000 Newton per coulomb, or you might put it in unit volt per meter. Okay, both is accepted. Then we're done with the question.